All right, looks like we've got a few attendees that have joined us already. We'll just wait a few more minutes before we start, just to allow some of the other attendees to join in the session. So just bear with us for a moment. Yen, just repeating my earlier message for attendees that have just recently joined. We're going to wait a few more minutes just to allow more attendees to join this session before we kick off. All right, that looks like we've got enough attendees to kick off. So hi everyone, and welcome to this Azure Red Hat Openshift for live webinar. So you'll notice that there's a Q&A window in your web page. So feel free to ask any questions during this webinar. Just type in your question in there, and one of the speakers will try to answer that during the session. So today we've got folks from both Microsoft and Red Hat presenting. So we'll briefly introduce ourselves. So I'm Clarence Beckett-Zetas, an Azure technical specialist working for Microsoft. So I'm based out of Melbourne, Australia, and I focus on cloud native solutions. So that includes things like container platforms, serverless DevOps, and of course, open source software.
You're on mute.
Tēnā koutou katoa, ko taranaki te maunga, ko pātea tako awa, no whakahurangi aho kei paniki tōku whare, ka mahi aho kai whakahoahoa o tinga, ko Joel tōku ingoa. No reira, tēnā koutou, tēnā koutou katoa. For those of you who don't speak te reo Māori, my name is Joel Pauling. I am originally from Taranaki, but I live in Wellington. I am a senior solution architect with Red Hat New Zealand, prior to that working in large telco cloud deployments in North America, South America, and Asia Pac for the last sort of 5 to 10 years. I am currently a platform and cloud specialist with Red Hat New Zealand. So I do infrastructure, that's Red Hat Enterprise Linux, OpenStack, OpenShift for the platform side of things, and Ansible automation.
Yeah, and my name is Michael Calizo. I am a senior solutions architect based here in Wellington as well. Originally from the Philippines. I started with Red Hat 3 years ago as a senior TAM, managed to make my way up to principal TAM, and now I am working as a senior solutions architect with focus on OpenShift.
Great. Well, thanks for the intros. So we'll move on to the agenda for today. So this is what we've got planned for you. So we're doing the introduction at the moment. We'll focus a bit on the the partnership between Microsoft and Red Hat, and then we'll move on to probably the part that you're most interested in today, which is a product overview. We'll look at the features and some of the architectural aspects of Arrow. So Arrow, from now on, I'll just say Arrow instead of Azure Red Hat Openshift. Then we'll look at how to get started. So how do you create your first cluster? How do you spin up the cluster, deploy your first app? And then we'll hand over to Mike, and Mike's going to run through some demonstrations using the OpenShift web console around the administration and development perspectives. And lastly, we'll close out with some of the Azure native integrations that kind of complement the OpenShift container platform. And at the end, we'd ask if you could also provide any feedback so that we can improve future sessions. So before we go into Arrow, let's have a look a bit around the partnership between Microsoft and Red Hat. So here we've got Satya Nadella, the current CEO of Microsoft, and we want to highlight the strategic alliance that we have between Microsoft and Red Hat, primarily centered around the open source collaboration. So I'm just going to read this quote from Satya. He attended in person at the Red Hat Summit last year, and he said that Microsoft has embraced open source primarily because it's driven by what he believes is fundamentally what the customers expect us to do, which is to say, doing what's best for both companies' customers. Microsoft has a heritage here. We are developer tools company first, and now, of course, we are all in on open source. So what's interesting here is you might not associate Microsoft with open source, given its long history with proprietary products like Windows and Office, for example. Whereas Red Hat has its roots in open source, starting with Linux. Now, this has all changed with customer needs and the prevalence of open source in the enterprise. So customers have expectations nowadays that there's a consistent hybrid cloud environment, and this is where OpenShift squarely fits within. So Microsoft's been around for a long time, founded 45 years ago in the PC era, and we've come a long way. Now you see that we're across more than 95% of Fortune 500 companies. We trust the business on Microsoft Azure, which is a leading hyperscale cloud. And our strength is in adapting and listening to and enabling customers such as yourself on this webinar today. Next slide, please.
So I guess I'll talk a little bit about why Red Hat's at the table here. This slide kind of speaks to our pedigree. So we like to roll this particular stat out quite often, but we're quite proud of it. So 100% of Fortune 500 and global Fortune 500 leaders are using Red Hat products and services. We're represented in every industry, including aviation, telecommunications, and healthcare, and banking and financial services. They all choose Red Hat because we have a broad portfolio and a history of delivering business value from open source solutions that meet the needs of the enterprise. It'd be fair to say that historically, Microsoft and Red Hat's relationship hasn't always been warm. However, that changed sometime in the last decade. And in fact, Red Hat and Microsoft's partnership goes back to 2015. So the strength of this partnership has been built on the foundation of our work to develop joint support for Red Hat Enterprise Linux, including our operating systems on each other's respective VM hypervisors. Our learning and growth from that work has demonstrated the unique customer value that we can deliver to enterprises when we work together. Since then, we've collaborated on bringing a lot of Red Hat solutions to Azure, as well as bringing Microsoft technology to Red Hat customers. A notable example of this is that Red Hat Enterprise Linux is now the preferred platform for running Microsoft's flagship database product, SQL Server. At Red Hat Summit last year, we announced the general availability of Azure Red Hat Openshift. And this was the only first-party, fully managed Red Hat OpenShift service on a public cloud. Last month, Azure Red Hat OpenShift 4 became generally available. OpenShift 4, launched last year, offers a raft of exciting enhancements, which are now available on Arrow. So Kubernetes has become synonymous with container platforms. And today, many customers are building these platforms as they move towards a cloud-native development practice. But using Kubernetes directly has a steep learning curve, and Kubernetes in an enterprise setting is hard to get right. Compliance, security, and reliabilities are all considerations that you need to plan for in any well-planned-for enterprise project. And these considerations are exacerbated by the fact that Kubernetes upstream projects are a rapidly moving target, and they're constantly evolving. A stat that we like to talk about last year is that 95% of the Kubernetes code base changed over the preceding 12 months. So any ecosystem which uses that upstream Kubernetes must also rapidly change to match. So if we look at the type of things that we see that you need to do as an organization to deploy Kubernetes, we can see that there is an installation phase where you've got the templating and validation steps that you need to carry out. You've got a deployment phase where you have to integrate with your existing IDM and security access management, your monitoring systems, and all your egress and ingress points into your Kubernetes cluster. Then you have a hardening phase where you have to do the security compliance steps and security validation and certification steps to make your network teams happy. And then you have to operate it. And day two operations have traditionally with Kubernetes been a hard and difficult process. So Red Hat was keen to ensure we learned from our 9-year journey producing and supporting a container platform. And with OpenShift 4, we concentrated on what customers were telling us as guiding principles for features in the platform itself. The key reasons for choosing OpenShift are reflected in the results of our research. Every time we went out to survey what were some of those issues and challenges that companies faced, we would hear about container security and compliance, day two management, install, and upgrade, and app dev and management challenges. On the other hand, prospects are looking for a vendor with a demonstrated leadership and contributions to open source communities. Platform security, long-term commercial support, that's all what Red Hat has done for 26 years. That's our business model. So reflecting on these anecdotes, thinking about where your organization is or where your development methodologies are today, where are you in your container adoption journey? What technologies are you looking at currently, and what do you consider critical capabilities in your selection process in terms of both product and vendor capability? Here's how Red Hat have addressed container adoption challenges with OpenShift 4 and how value provided by Red Hat OpenShift contributes to addressing each of these challenges. We take container security very seriously and take a holistic approach to deliver what we call a trusted enterprise Kubernetes platform. As you know, containers are Linux or introduced Linux kernel features in other operating systems, and so is Kubernetes at its heart. Building on a 26-year history of providing supported security hard in Linux, which is trusted by thousands of enterprises worldwide, we deliver the same secure platform across the container stack and stand behind it with long-term support. We recognize that keeping up with the frequent upstream releases can be challenging, and we've invested in automating capabilities by technologies like the operator framework and over-the-air updates to make it easier to keep up to date with the latest innovations coming out of the communities and to be able to deploy containers at scale. And it's all about the developers that we're investing in. We've invested in automation capabilities within OpenShift, i.e. the continuous integration, continuous delivery pipelines, A/B testing in the way that your images are deployed in the platform. We've invested in developer tools like code-ready workspaces, and we've invested in cloud-native frameworks, including Spring, serverless, and Windows containers to inspire developers to create the best code, no matter what applications they're building. Chances are you can probably improve your developer productivity with OpenShift. So there's several key reasons why customers have been choosing OpenShift. OpenShift delivers a trusted enterprise Kubernetes platform with the containers are Linux. And you know, the Red Hat Enterprise Linux is the best enterprise Linux distribution in the industry. Obviously, I work for Red Hat and I would say that, but Gartner backs us up here. RHEL is also the foundation for Kubernetes, with features built into the operating system like SE Linux controls, Cryo runtime support, Podman, Builder, and Scopio tooling to replace proprietary or specific implementations of a container platform. So with those tools in place, we're able to put CoreOS, which we acquired several years ago, at the heart of an immutable platform for running the container orchestration engine. CoreOS, Red Hat CoreOS, is an immutable container-optimized RHEL image, and it's designed from the ground up to run containers. And it features things like TLS encryption, namespace, and authentication for everything that's provided in the platform itself, all the way up into the stack. This trusted enterprise container platform also provides a consistent layer across every cloud environment that enables developers and operations teams to work together seamlessly. Customers also choose OpenShift because we support a very broad range of applications, from traditional J2EE to modern application frameworks like Spring, Django, and analytics platforms like Spark and TensorFlow. Developers are more productive when they build applications on OpenShift. Last but not least, open source leadership and contributions are the top reasons for customers to choose Kubernetes vendor, and Red Hat is known for its open source leadership. As an open source is becoming a standard in enterprise, we also help customers participate and contribute in these communities, and OpenShift Commons is a great opportunity for organizations to engage with these.
Sorry, I fell for the mute button. Yeah, great. Thanks, Joel. I really like this logo here, and want to highlight here that now you understand the strengths of Microsoft and Red Hat and what this partnership brings out. The best of both worlds, and Arrow is really the result of a jointly engineered and supported effort, leveraging talent, innovation, and open source leadership from both companies. So you can take advantage of the security, the robustness that Joel was talking about around OpenShift, and also the flexibility and elasticity of Azure and its broader ecosystem and services. So if you look at, if you were to run Red Hat OpenShift yourself, using infrastructure as a service, here we can see what that would look like running that on Azure. So there's a lot of moving parts. You'd end up managing a lot of stuff yourself. So you were supporting all the infrastructure. You got to create the cluster, manage the networking, monitoring, logging, patching, high availability, etc. This takes a lot of time and effort. You can offload some of these responsibilities if you're, for example, working with a managed service provider, but that does eat into your IT budget and takes away some of the self-service benefits of having a managed cloud platform in the first place. And if we look on the next slide, we can see what Arrow provides. Click on the, yeah, cool. So you can see here, essentially you're presented with a control plane. You have a CLI, there's an API, there's the web console, but everything underneath is really a black box from your perspective. So Microsoft and Red Hat are taking care of operating the infrastructure, applying practices, security best practices, monitoring and operating the VMs. So we're really simplifying the cluster operation experience, and you can focus on building and deploying and scaling apps with confidence.
So Clarence has given you a brief architectural view of some of those Azure components. Let's have a look at the OpenShift container platform at a glance. So the power of the platform is seamlessly integrated capabilities that are available to you out of the box. And beyond this certified Kubernetes orchestrator, OpenShift incorporates all the infrastructure components required in a properly designed container platform that you might not get with a standard Kubernetes distribution. So if we look at it from a top down, some of those extra additional infrastructure services that need to be built and supported in a container platform that are included with OpenShift are cluster services. So these provide things like the registry, the logging, showback monitoring. These are all built in and available by design inside of OpenShift. We look at things like the service mesh components by way of Istio, Jaeger, and Knative serverless foundation, frameworks. And all these things allow us to do serverless and function-based programming, which is so hot right now. These are all provided alongside certified middleware runtimes as well. So not only that, you've got the Red Hat certified middleware stack, but we also make available third-party integrated software vendor stacks through our operator marketplace. So within OpenShift's dashboard, you get all of these features and functionality straight up. Mike's going to go over some of these later on in his demos, in particular the Knative serverless functions. But it's important to note that that is all capability which you have to build yourself if you go with an upstream-based distribution. If we look at the developer services that are included with OpenShift, we've already kind of touched on some of these, but we have a continuous integration delivery pipeline using a lightweight CI/CD platform called Tekton, and that is built into OpenShift itself. These components are specifically designed around a container native development practice. And so this allows you to have a full source to image capability within the platform delivered via a browser developer IDE environment. And inside of OpenShift, we call this code-ready workspaces. All of this is built on Red Hat Core OS, which is delivered as a zero-touch platform layer, managed from within OpenShift itself, like any other container workload. This immutable OS technologies enable the seamless roll forward and roll back and upgrade of the platform delivered on the same finely tuned enterprise Linux kernel and hardened user space tools as enterprise Red Hat Linux. These are the same capabilities that are available anywhere OpenShift is deployed to, but matched and tuned to Azure's specific strengths and capabilities by Red Hat and Microsoft in the Arrow offering. So going into some of those features a little bit more deep on this slide, let's examine the new capabilities in OpenShift 4.3 and Arrow. So I'd like to highlight that OpenShift 4.2 now is 100% FIPS compliant. And so this is a big thing, especially in the financial services and government areas, in that things like encryption of data at rest and in flight are now 100% certified and guaranteed in the OpenShift platform. 3 years ago, Red Hat acquired Core OS, and as part of the acquisition technology, like the container registry scanner, Clear, and the container Linux OS itself have been incorporated into OpenShift 4. This makes the key infrastructure components as small a management and security surface as possible, leveraging Red Hat Enterprise Linux hardened and quality assured kernel and user space libraries in combination with the roll forward and roll back capabilities of Core OS. OpenShift 4 allows for full operation of the entire cluster platform within the Kubernetes dashboard. And until you've seen that in action, it's really hard to appreciate just how cool that is. And this is all delivered through the operator technology that Mike's going to talk a little bit about later on. Effectively, operators codify and automate the standard operating intelligence that you might use as a system administrator into a discrete package that you can install and use within the Kubernetes platform. The installation of OpenShift 4 itself is a single Go operator binary, which then installs itself into the Bootstrap cluster and allows for the seamless day two operations to enable as close to possible zero ops experience as we can deliver. And on security, Red Hat has worked with all the components of the Linux user space to build up to the RHEL 8 release last May. And this was to ensure things like TLS 1.3 and stringent FIPS and other cryptographic security compliance certifications could be met with the RHEL 8 release. Once we had that, we've been able to take that to all of our other platforms. And these enhancements are incorporated into the OpenShift 4 platform, meaning you can rest assured that regardless of where you choose to deploy OpenShift, that it will include capabilities such as encryption at rest and in flight and FUNA token authentication. Beyond this, OpenShift 4 comes ready for serverless functions, which I've already touched on, and this supports microarchitectures and massive resilience and scale up and down to zero. These are enabled through the service mesh capabilities and the Knative support. And the best news of all is that it's available today.
So here we can see obviously a map of the world, and what we want to highlight here is that Azure has presence around in many countries. So we've got 58 cloud regions, which is more than any other cloud provider. And if we focus in or zoom in on Asia, we can see there's seven regions that we have there. The ones with green are where Arrow 4 went GA. So actually it was just on the 28th of April. So very recently, about 2.5 weeks ago, Arrow 4 went GA. The other regions you can see there are still on Arrow 3, version 3. We'll progressively be rolling out 4 to those regions in the coming months. And some good news, soon that number up there will be 8, because about a week ago, Microsoft announced we're opening a region in New Zealand. So Joel and Mike will be happy because they reside in New Zealand.
Yeah, the Prime Minister even gave you guys a plug the other day.
Yeah, that's right. That was unexpected but welcome. We'll move on to the next slide. So just on this one here, we just want to highlight some of the changes that have occurred between Arrow 3.11 and 4.3. So today, we'd direct you to Arrow 4 because of a lot of the new benefits that you get. So Joel's already touched on the OS differences there. And you'll see that the underlying Kubernetes platform is also more modern. It's moved up to 1.16. Interesting thing is the minimum cluster. So if you want to create an Arrow cluster with all the defaults, you just spin the new cluster up. This is what you would get. You would get 3 master nodes and 3 app nodes. And the minimum requirement in terms of node size is detailed there. So an 8-core VM for masters and a 4-core standard VM for apps. Now you can change those to larger sizes, but that's the minimum footprint. One of the most requested features from customers was they wanted cluster admin. So you can see that that's now provided. So that enables a lot of things like installing operators and Helm charts and CRDs and so forth. And you can also turn on privileged container access if required. So you have a lot of control. There is a support policy we've published on our website that says what you're allowed to do. So obviously if you go mess around with some of the system components, then it could violate the support policy. But in general, you have the ability to administer your cluster, assign new roles and so forth. Let's move on to the next one. So we'll just touch on some of the new features here before we go into some demos. So when you create a new Arrow cluster, you're going to have to assign an identity provider. So initially you get this special user called kubeadmin, and you get a password. You can retrieve a password for that user. That's meant to be just a temporary user, and then you choose your favorite identity provider. You can see this extensive list there, and you can also use Azure Active Directory to single sign on. And we'll cover that a bit more further in the webinar. Another key feature is the ability to have a private cluster. So by default, you'll have a public API server. So in terms of working with the CLI or it's called the OC command line interface, that's a public endpoint that you can then communicate with. A lot of customers don't want that. They want to have it all private. So you can turn that to a private endpoint. Of course, if you do that, you would need a way to access your server, your cluster from administering it. So you'd either need like a Bastion host or some way to route to that private network through potentially like a VPN or ExpressRoute. You can also have a private ingress. So for end user workloads, so APIs and web apps that you're running, for example, in the cluster, if you don't intend to have any of your applications publicly exposed, you can set that to a private ingress, and then of course you can access those endpoints within your on-premise network or other peered VNets. So we're continually upgrading Azure regions to support availability zones. You need to check our documentation to see which regions currently have availability zones and when they're on the roadmap to be upgraded. So if you do choose a region with availability zones, good news is that Arrow will automatically distribute your nodes that you create or your VMs under the hood across all those AZs. So for example, if you looked at, say, US East, for example, which was the first region we enabled Arrow for, you would get the 3 master nodes spread across 3 AZs, and the same with the worker nodes.
So I guess this is just reiterating the FIPS compliance. And I guess this has come up since the announcement of the New Zealand Azure region, and that Microsoft are a US-based company. They potentially could be compelled. And so having a platform on top of Azure that also works with Azure's security features allows you to meet your compliance obligations. And OpenShift is able to deliver that.
So from a support and operations perspective, you can see that Microsoft and Red Hat work closely together. So we have a unified support. We have essentially a single V team of site reliability engineers. And whenever you have a problem with your Arrow cluster, you just use the one channel essentially to raise that concern. Now you could raise it through the Red Hat portal. You could raise it through the Microsoft Azure support channel. It will be triaged, and there's communication both ways between both teams, and that will end up going to the right team. So, for example, if it was more of a underlying platform issue, that would get routed to Microsoft. If it was more about OpenShift internals, the base OS or the middleware or other components in OpenShift, then that would obviously go to Red Hat. But we have access to each other's support system through single sign-on.
Yeah, and I guess, so together you have the experience of the second half of the establishing organization behind Kubernetes, which is Red Hat, by the way, which I think I have to highlight because I think people don't realize that. So you've got 26 years of experience, from a company that is used to dealing with delivering rapidly moving, innovative open source into these stable, secure, and supported business value-oriented products. And so with Microsoft as the partner that lets you use that pedigree today in a familiar and scalable fashion with a cloud partner who, in the back end, we're working with intimately to make sure that you're successful.
So on the next slide here, we can see at a high level what the underlying architecture for Arrow looks like. Now, as I said, as an end user, you don't need to really be concerned about this, but this is just more for your kind of understanding of what's being managed under the hood. And this can change over time, but currently this is kind of what you would get. You would get your master virtual machines, and then your worker virtual machines there, protected by a security group. And then if you look on the right-hand side, by default, you'll get an internal OpenShift container registry. if you're already using Azure, you might want to use the Azure Container Registry. So we set up what's called a service endpoint from your cluster to the Azure Container Registry, which allows for private routing over Microsoft's backbone to that PaaS service rather than going over the internet. You can also peer to other virtual networks within Azure, and you can also, if you have ExpressRoute set up to your on-premise, you can then access infrastructure there. If you look over on the left side of the diagram, you'll get a mix of public or internal load balancers depending on your options. So if you, for example, if you've set private ingress, you'll have just the internal load balancer. If you've set private API server, you won't have the public load balancer and public IP exposing your API server. And then you'll have also Azure DNS, so either public or private zones, depending on your options during setup. And the last thing I want to highlight there is the management plane. So Microsoft and Red Hat can administer your cluster through what's called a private link service. So even if you've set your cluster to be private, we need to be able to access your VNet to manage your VMs as part of SLA. So we have that capability. So that was a high-level introduction into Arrow and the main sort of features and what's new. What we'll look at now is how to get started with Arrow. So both Microsoft and Red Hat have extensive documentation on Arrow, and you can see what that kind of looks like here in the URLs. Now, Microsoft stocks will be primarily pertain to setting up the cluster in Azure, integrations with Azure and so forth. And what you'll find is Red Hat's documentation will be more comprehensive on OpenShift itself, the configuration of OpenShift and its features. So you can kind of use both of these sources of documentation to get you going. So from a cluster creation perspective, if we advance forward, please, what you'll find is there's a single command to create a cluster. So if you're familiar with Azure and you've used Azure CLI, there's this command called AZ. So you can do AZ arrow create and then pass some parameters, and then after a while you'll have a cluster up and running. So we'll go through what that looks like in a demo shortly. We have a very easy to follow tutorial, and we're actually going to look at this in a minute, which guides you through zero to hero, so to speak, creating a cluster from scratch. And a summary of those steps is highlighted here, and we'll go through this in a moment. So you'll have to install an extension to your Azure CLI that understands arrow commands, register your subscription to have access to the OpenShift resource endpoint. That's a one-off thing, and then you can create a VNet with 2 subnets. So that's really the only bit that you have to kind of provide, the VNet. After that, it's just a single command, and you can see that on the right there. You create your cluster. You can choose whether you want private or public visibility on your API server and ingress endpoint, and then you retrieve your credentials to log in with that initial user we talked about, which was kubeadmin. So we're going to now run through a demo of creating a cluster. And just for transparency, this is recorded. We just felt it was easier with multiple people to record these, and we'll walk you through the process to play that video. All right, so here we are at the tutorial page that I was talking about, and it's very straightforward to follow. You will need an Azure subscription to get started. So in terms of prerequisites, you need to create a virtual network and 2 subnets. And once you've done that, then you can go ahead and deploy your cluster. So currently, the experience is CLI driven. If you're automating your cluster, it's most likely that you would be using some sort of CLI tool or script, potentially ARM templates, and probably in the future we'll have updated the Terraform plugin as well. For this tutorial, we just use the CLI, and we are working on an integrated UI wizard experience in the portal that's currently in development. So here I'm just showing you that I've got the Azure CLI installed in my terminal. So once you've got that installed, you need to install an extension. So Azure CLI supports extensions for new services and components like that. So here I'm adding the Arrow extension. And you can see I've already got it installed previously, so it was pretty quick. And now you'll see I can type AZ Arrow and I get all these sub-commands. So I can create a cluster, delete, list, and then retrieve my credentials and so forth. Now, this is a one-off step you need to do. So everything in Azure is represented by a resource provider. So there's one for Red Hat Openshift. So for your subscription, you need to register your subscription to have access to that provider. So essentially it enables the API in Azure for your subscription. So that's now registered. And what we'll just do, one final step, verify that my CLI has the Arrow extension installed. So under extensions, you can see there Arrow extension is installed. And you can run an update on that periodically, just to check for changes. Now this step here is optional but highly recommended. It's essentially downloading what's called a pull secret. So if you work with registries, typically you need to have a pull secret to access them to be authenticated. And this will give you access to Red Hat's official container registries and additional content such as officially supported operators that we'll cover more later. You can use a free account. You just sign up at Red Hat's website and then click on that link and you can download this secret as a text file. So I'm just listing on my file system here that I actually have the pull secret. I'm not going to display it because it's actually a secret. So now we can proceed to starting to create the resources we need. And because we're working from the command line, we want to save typing, so we define some environment variables. Here I'm just using the defaults. You could use a location where Arrow is available, for example, Southeast Asia or Australia East, for example. I'm going to call my cluster, and then the resource group name is there. So the first step is to create a resource group. So if you're new to Azure, a resource group is essentially just a container that houses one or more resources. You need to have all resources within a resource group, and it's also a security boundary, so you can control who has access to that resource group. Now we're creating the VNet, so the virtual network. It's very straightforward. The hardest part of this is deciding what network address range you want to use. Now, why that's important is if you've got an isolated cluster that doesn't integrate with other networks, it's fine. But if you're doing VNet peering, for example, or peering with an on-premise network, you need to ensure that that network address range doesn't overlap with any other networks. So once the VNet's created, we can go ahead and create the two subnets within the VNet. So there's one for the master nodes and one for the worker nodes. And you'll see there the service endpoint we're enabling. If we use container registry, then that's set up for us to then talk to container registry securely. Now this last step there, where it says disable private link service. So what I was talking about earlier was that Microsoft and Red Hat need access to your VNet via our management plane through this private link service to be able to administer your cluster. If you don't do that, you might potentially lock us out from having access to your VNet. So we're just saying for the private link service, disable any network policies you've defined so that we can have access to your VNet. I tell my kids over there to be quiet. Quiet, boys. There's a lot of people on this call. Sorry about that. So, so now we've created the VNet, the subnet, sorry. And it looks like I accidentally forgot to type in the worker subnet creation step. So just run that final one. So now we're up to the interesting part, which is creating the cluster. You can see there's a single command. So essentially, you just saying what resource group, what name, VNet, and then mapping the subnets across. And there's other options you can pass, even ones that are not listed here. For example, if you want to change the number of worker nodes or the size of those VMs, you can override the defaults here. So what I'm going to do is I'm going to pass in that full secret that I've downloaded previously. So I'm just going to add one more parameter here called full secret. And shortly it will say running. That takes about 30 to 35 minutes to fully create your cluster. So provision all the VMs, set up the load balancers, set up everything else that's necessary. That we kind of saw a high-level overview of what that looks like in the architecture diagram earlier. So of course we're not going to wait here for 30 minutes, which is one of the benefits of having this recorded. It says running now, so what we'd do is we'd come back to that. What I'm going to show you here is if we list the clusters that I have defined, it will say that one of those clusters is now in creating state. There it is, creating, and you can see there's 3 worker nodes. So you can scale those worker nodes up further. You can scale further down, but you can't. You shouldn't go below 3 nodes because that would violate the support policy. Right, so time passes and our cluster's now created. You'll notice we're presented with a URL. So that URL is to gain access to the OpenShift console, which is a web interface. If you've used OpenShift Container Platform before, other than it saying Azure in the title there and the URL looking different, this looks and feels just like any other OpenShift Container Platform. So now we're going to log in with the default user, which is the administrator user, and there's a command that you have to type in to retrieve the password for this user. So normally what you'd do is you log in with this user and then define and set up your identity provider, and then you can disable this user. Now, I'm not going to execute this command because that would show the admin password, and I still have this cluster actually running. So I'm doing off-screen executing that, retrieving the password. I can now paste that in to log in. And in a moment, there we go, we're logged in, and you can see there's a message that says I'm logged in as a temporary administrative user, and it's prompting me to set up some identity provider. So you can see everything's healthy, the cluster, the control plane, everything looks good. And I'll just quickly show you here, this is where you can add the other identity providers. So via that drop down. It's very straightforward, and there's comprehensive documentation both on Microsoft's website and Red Hat's OpenShift documentation. So here, if you want to log into the CLI, you can click that menu button to get a token that you can use to log in, an auth token. You can actually log in with a username and password as well, or you can do it this way where you get a temporary token, time-limited token to log in. So now I'm logged in, and I can use the OC command line tool. So I'm just checking the status of my cluster. And in our docs, which is actually the second tutorial that follows on from the one we just looked at, it explains how to install your CLI tool. So what you'll do is you just go to the help menu in your cluster, command line tools, and you can find the appropriate CLI tool for your operating system of choice. So that was the demo of creating a cluster. As you can see, it's fairly straightforward to do that. So now that we've got our cluster, we want to do something with it. So let's imagine now we're a developer. We've got this new cluster, and we want to deploy an application. So the application we're going to deploy is one that presents a web interface that allows you to vote on your favorite smoothie. Unfortunately, there's no mango in there. Joel's complaining because we don't have mango in there. From an architectural perspective, the way this is implemented is it's a microservices application. There's a web app that uses Vue.js. It's hosted out of a Node runtime. And then the API is a RESTful API, the JSON API, that runs in Node as well. And the backend state is stored in MongoDB. Now here, MongoDB is running inside the cluster using persistent storage, which maps to an Azure disk. Of course, you could run your state outside of the cluster if you prefer to do that. So let's go into the demo now of deploying our first application. Excuse me. So here we're back at our OpenShift cluster that we were looking at earlier. I've got some instructions, and you can follow this yourself once you create your own cluster. So on GitHub, I've put some instructions on how to deploy this microservices application. So anything you do on OpenShift will require a project, essentially. Like say you want to deploy something, you put it within a project. Project is from Kubernetes objects, it maps to essentially a namespace in Kubernetes. So it's an isolation boundary, and it's also a folder to house your artifacts, so your services, deployments, pods, etc. And it's also a security boundary. So now that we've got the names, the project or my demos, I want to deploy MongoDB. Now, just let's say I'm not a MongoDB expert. I'd rather use a recipe that tells me how to install it, or it's already been codified with expert knowledge. And that's where I've just listed the built-in templates. And you can create your own templates. So there's a bunch of them there for databases and middleware that come built in. So here I'm listing what the MongoDB persistent template would do. So if you're familiar with Kubernetes, this is just the Kubernetes manifest. Now don't be scared by Kubernetes, like I'm mentioning that just for your knowledge, but you don't really need to know a lot about Kubernetes to work with OpenShift. It simplifies things greatly. So now that I've found the template I want to use, I'm just overriding some of the parameters to set the username, password, etc. And lastly, I'm passing that to the OC create command, which will execute and create all the underlying objects for our database instance. So if we jump back into the console, you can switch to the developer perspective. And here there's a what's called the topology, which shows you a visual representation of your project assets. So you can see MongoDB is showing up there, and it's currently deploying. So it's pulling down a container. And you can check the logs at any point in time to see what's going on. And for example, if you encounter an error. So now we have the database. Let's deploy our API. You can see that the API is residing on GitHub, so you can see the source code for it if you want to check that out later. So the way we deploy an app is using new app, and you can choose different deployment strategies. Here I'm using source to image, where I don't even need to worry about creating a Docker file or creating a Docker image. I just say, hey, please deploy my app from this source code repository. So what will happen is a build will be created inside the cluster for me automatically, and then my container will be deployed from that built image. Because the API needs to talk to MongoDB, I'm setting an environment variable and passing that through to the API. So you can do that from the command line, or you could also do it from the UI. So now DB is running. You can see the blue circle around it, which is a visual indicator. And for the API, I just want to jump into the deployment config for it. And I can show you that that environment variable that I set from the command line now shows up here. And of course, I could do that through the UI as well. So now we've got the API. The last step is to deploy the front end. Again, I'm going to take advantage of the source to image build strategy. So I'm executing another app within the same project. That's where the source code resides. And it also needs an environment variable so that the web app can talk to the API. And you'll notice here, the API is a short domain name. It's not an SQDN or fully qualified domain name. And that's because within the cluster, you can resolve services within the same project using a short name. You don't need a fully qualified name. So that's essentially an internal DNS reference. Now, because this is the front-end web app, I want to expose a route. So the route is kind of like an ingress endpoint where you get a URL that allows you to externally to then route to that web app or service within the cluster. So here I'm just listing the route that was generated. That route is publicly accessible. And if you go to the topology view for the developer perspective, you can see the APIs up and running, the MongoDB is up and running. A web app is currently building for us. And that little icon on the top right is the route endpoint. And if you click on it, the URL will open up in another browser tab. So you can see the experience in deploying apps with OpenShift is very easy, and it's a great developer experience. So if we jump into the logs, this is the build logs for the web app. You can see that it's currently installing some npm packages because it's a Node app. It's a Node app. It uses Vue.js, and it's the front end. And then here we can see now where we've built the image and we've pushed it to the internal registry. That will be the default registry unless you specify a different registry. So if we jump back here, it's currently light blue now. What's light blue mean? Light blue means we're creating the container for the underlying pod. So that's Kubernetes terminology, but essentially your container runs within a pod. And lastly, everything's blue, so we should be able to access our web app, and there it is. So very straightforward. There's no messing around with Docker files or understanding container images. I just use the source code to get this up and running. So I'm voting on my preferences for smoothies. Submit that. And I just want to show you that if you jump into the logs for the API, you'll be able to see when I vote, the JSON ratings will come through. So just then jump back here and you can see there. So they're all the ratings that were submitted and received. So it's quite a nice developer experience. You can interact with your app and then check the logs, the live logs. You can deploy this application yourself on your own cluster once you follow the tutorial and then jump to that GitHub link that I showed earlier. So that wraps up the second demo, which was deploying your first application. So I hope that you found that useful and see how easy it is to work with OpenShift. So now Mike's sitting there patiently, very quietly. So it's his chance now to tell you all about the administration development experience in OpenShift.
Cool. Thanks, Clarence. Now that you guys, I hope, understand and get how easy you can deploy OpenShift in Arrow, what I'm going to show basically are the more advanced features of Arrow 4.3. And not only advanced, but exciting features that we bring into this platform. So things that I will be talking and doing a demo is about operator and operator hub and how you can use that operator. And I'll be doing a demo as well for service mesh and serverless. So an operator, how did we arrive and get this operator? So I'll just give you a little bit of background. The Operator Hub was launched by Red Hat and our partners like Microsoft, AWS, and Google earlier this year. It provides a single place on the internet for developers to publish operator and for customers to find and consume curated operators. These operators meet certain quality standards, so you can have confidence they will deliver what they promise. You can deploy these operators on any Kubernetes distribution, by the way, not just OpenShift. But we also integrated Operator Hub in OpenShift, and that's what I'm going to show in a bit, where you can also find fully certified operators from our partner that meet a very high standard of quality. In OpenShift, we have two kinds of operator. These are certified operators, which are supported by software vendors like Red Hat and other partners, and community operators, where you need to rely to get the support from community. Currently, in OpenShift, we have about 100 plus certified operators available. Next slide, please. So an operator is a way of managing Kubernetes application. A Kubernetes application is deployed in Kubernetes and also managed by Kubernetes. This is a cohesive set of APIs to service them and manage your application. Operator automates action usually performed manually. Simple operator could just do a simple application deployment. An advanced operator could provide you a day-to operation activity, such as automation, backup, and recovery, as well as updates. In reality, the reality is that maintaining containerized application requires manual intervention. This becomes difficult at scale. Imagine if you have services or containers running in OpenShift. The worst thing that can happen in your production is that a manual process creates misconfiguration that can leave systems vulnerable. Kubernetes operator changed this. Operator extend Kubernetes to streamline and automate installation, updates, and management of container-based services. With operator, Kubernetes run and manage containerized software according to the best practice. And this is possible through the operator control loop that continually checks your cluster to ensure your described ideal state. Next slide, please. So now what I'm going to do, because I introduces you to operator on a high level, I'm going to actually use operator by deploying couch-based database cluster, as well as to show some of those functionality on the operator hub attached or in OpenShift platform. Can you play the video? Yeah. So here I am logged in as admin. I went to the operator hub, which is available on Arrow 4.3. And in here, it reflects all the available operators that I can automatically use and brought as part of the installation. These operators are categorized depending on their usage. And I can even see whether I have an installed operator already that I'm using. And of course, the operators that are not installed yet. I can also see from the operator hub the operator providers like Red Hat operators, which has 33. Certified operators, which are basically operators from our partners, as well as community operators that are available for you to use. Also, I can see the providers if I want to dig deeper into specific operators. An example for that is Anchor, for the security operator for scanning. And I can also find the level of capability, meaning if it's basic operator or advanced operator. Now, let's try to use this operator. What I'm going to do now is I've created a couch-based demo project, as what you always need to do in OpenShift. You need to have a namespace for you to deploy an application, as explained by Clarence earlier. Now I'm going to look for couch-based operator, the operator that I'll be using to deploy a 3-node cluster of Couchbase. So when I click Couchbase, I already be presented of what the operator can do, who created it, and who supports it, as well as what are the required parameters before I can use this operator. Now that I understand that, I'll click the install. This will open a new window where I can select which namespace I'll be using, whether I'll be using a specific channel. And after clicking subscribe, that will install operator. So now that I have an installed operator, what I'm going to do is actually to deploy a cluster, because this is just, this operator just deployed an operator so that I can deploy a Couchbase cluster. When I click install, this will give me a window where I can configure what features of Couchbase I will be enabled. And of course, I need to change the auth secret because that's one of the requirements. Earlier, I've created an auth secret already on that namespace that we created. For the sake of this demo, to shorten the installation, I'll be removing analytics. As you can see, I'll be deploying 3 nodes cluster for Couchbase. And if I go to my command line, I'll do OC get pads watch. You can see that the operator is now deploying containers. Now that the containers are created, what I'm going to do is I'm going back to the operator again, installed operator, while I'm still in the Couchbase demo namespace, and check and see if my deployment is done. After deployment, you still have parameters that you can change in this operator. And I can do that using UI. I can do that using command line by editing the CRDs. Now, what I'm going to do, because I am confident and done on installing, I want to make sure that the services created by this operator are available. But there is no route, so how can I access that? So let me create that route, use the service that for UI that we've seen earlier, and create a route. So in the command line, you just do OC, create route, OC expose the service, and this will create the route. Now, I will click that URL, and this will present me a Couchbase server UI admin login. So I'll be using the secrets that I created earlier, and this now gives me a Couchbase cluster. I can go to check the logs. I can check some security updates there. And what I'm going to do is I'll actually check the servers. I can see that the servers is not yet 100% healthy because of the deployment is still ongoing. Now, after a while, that is actually showing me a green cluster. So this basically, it concludes the operator demo, and showing you how you can utilize the operators that are already available in Operator Hub within OpenShift. Now I'm going to talk about Service Mesh. Next slide, please. So Service Mesh is another OpenShift 4.3 features that is delivered as part of Arrow that is very interesting and exciting in my opinion. So Service Mesh and how you use this basically depends on, if you basically organization move to build application using microservices, so they quickly face on managing complex interaction between instances and highly distributed microservice environment. And that's natural because while you're maturing on your container adoption, developers going to deploy more and more application because they can move fast now, but the data operation will be difficult for that. Traditional service communication in virtualized environment don't align with the requirements of microservices world, and there are some rethinking needed to architect the solution properly. Managing complex environment becomes DevOps problem. Developers are forced to create communication logic to its services. Often, they also need to add configuration server to manage this logic. With Red Hat OpenShift Service Mesh, these features brings behavioral insights and operational control to the service communication and traffic. It provides a consistent framework for connecting and securing, as well as monitoring containerized application inside OpenShift. Built in open source Istio project, Service Mesh provides control plane and infrastructure that's transparently enables this traffic management capability without requiring changes on developers' code. So Red Hat Service Mesh also augments Istio capability by adding and tracing observability in this deployment. Next slide, please. So this is how the Istio Service Mesh ecosystems looks like. So you'll have a Istio, which is the center of the universe that manages the control plane. You also Service Mesh in OpenShift also added Kiali, Jaeger, Grafana, and Prometheus for observability. In security perspective, using Istio, it handles mutual TLS authentication transparent to the service. For connection and control, Istio do rate limiting attempts to protect this service against a large amount of requests. An example for that is DOS. Next slide, please. And it's important to understand as well how Istio do this or Service Mesh do this. So in OpenShift, there is a concept called sidecar container. A sidecar container is a pattern where two or more containers are deployed in the same pod. The containers share the same namespace, network, and other resources, and all containers in the pod share the same lifecycle. So in the concept of Service Mesh, the sidecar pattern is often used to enhance the application container. In Istio, sidecar pattern is used to add container called envoy proxy. So you have a control plane which has Jaeger, Pilot, Mixer, and Auth, which is the native Istio features, and you will be adding envoy to your pod or your container to actually apply security route rules, policies, and report traffic telemetry at the pod level. Next slide, please. Next here is I'm going to do a demo on how you can use a Service Mesh features using a, an application called Book Info from Istio project, and we will be controlling a Java microservices where there will be multiple version of reviews that we'll be managing via Service Mesh. So here, I'm logged in again as an admin for now. I'll create a project where I'll be deploying my Service Mesh. So let's call it Istio Systems. Once I am done with that, I have a GitHub repository for this specific demo as well as Service Mesh that will be later on sharing with you. So what I showed earlier is for me to deploy Service Mesh on this OpenShift platform, I'll be needing 4 operators. First, we'll deploy Elasticsearch. So using the operator hub, I'll search for Elasticsearch operator. And then I'll just install this. And for this demo, I'll be deploying a cluster-wide Service Mesh. And of course, you can deploy this on a namespace specific service mesh. After deploying that Elasticsearch, I will deploy the second operator. This time I'll be deploying Kiali. And the Kiali operator, as earlier discussed, is used for observability. And again, I'll be deploying this operator for cluster-wide service mesh deployment. So I deploy it in the default project. Next, I'll be deploying Jaeger. Jaeger is used for tracing. And if you notice, when I deploy Red Hat supported operator for this purpose, because I want to make sure that if I'm deploying service mesh, I will get a Red Hat support as well. And of course, if you deploy that in Arrow environment, you'll get the support from Arrow team. Now I'll be deploying a service mesh operator. And after a while, the 4 operators will be installed. Now that the operators are installed, what I'm going to do is I'm going to actually deploy the control plane. So here, I want to monitor what's going on during this deployment. So I'll be doing an OC get pods and watch the progress when I deploy the control plane. So just like, because this is deployed using operator, I'll be using the default configuration for this. And as you can see in the command line, it creates multiple pods right away that will be part of OpenShift service mesh control plane. Now, what I'm going to show here is I'm actually going to the developer's perspective, so that while waiting for this deployment to finish, I can see and monitor what's going on in the namespace that I am currently with. Now that the deployment is done, I'm going back to my administrator's login, UI, and go to the operator. And then the next step for me is actually to create a service mesh role. So service mesh role controls which namespace or project I want to apply service mesh. So imagine if I'm touching a production environment, I will have multiple namespace, but I want to control book info namespace only. So that's what I did. After that, I now am ready to deploy an application that the service mesh is going to control. So I'll be creating a new project called book info. Going to the project UI, you can see that there is a new project called book info. Now I'm going to change this view to the book info namespace, so that when I deploy the application coming from book info construct, as you can see, the deployment is very quick because I did this the second time already. That means that the image is already available in my local registry, internal registry. Now that I have an application running, what I'm going to do is I'm going to apply the construct inherited from upstream STO to control the application. After that, I'll be creating a gateway for me to actually access the book info application. And after that, I'll be creating the destination rule, so that I can control all the destinations that's going to hit my application. Now that I'm satisfied with all the created resources, I want to go and check in the book info to show you the services that is running. Now in STO, I also see the same services, and then I can see the routes as well. The routes for my application, Yeah, and the routes for Jaeger. So let us open the Jaeger UI as well as the Kiali UI. Because this is the first time that we are opening the Jaeger application. It will ask for login. Now, this is actually the application that I just deployed. As you can see, what I'm showing here, I'm refreshing it to show that the application book reviews actually is doing a round robin because I haven't applied the control on the routes of the application. So here, I am trying to log into Jaeger earlier and then the Kiali. So Kiali gives me observability. And here I can view the graphs of a specific namespace where my application is running. And in Jaeger, I can use this for traceability to understand what's going on with my application and use this for troubleshooting purposes as well. So what I'm doing here is I'm sending traffic to my application in OpenShift so that I can see the traffic flowing as well, almost in real time in Kiali, so that I can observe what's going on. Here I'm changing the updates to 10 seconds. Now I'm clicking the application to view, to send more traffic. And as you can see, there will be a what do you call this, a round robin. All the apps that are running in my pods is being hit. Now what I just did is I actually created a route control to my application to allow only version 1 of my application to be accessed. Version 1 means no stars. And if you go to our Kiali UI, you can see that version 1 has 100% traffic going. Version 2 and version 3 has empty traffic. Now what I'm going to do is I'm going to change the logic and control the traffic that if a user JSON is logged in, it will only show black stars, I mean. And if I go to Kiali, I can see that actually it goes to version 2. The traffic goes to version 2 as well. Now, if I log out using that route control that I applied, I'll be seeing red stars only, as you can see earlier, and that means version 3 of my Java microservice application. Now, what I'm going to do next is actually to control my traffic and actually tell my STO, my STO or the service mesh that controls the routes to only use version 2, which version 2 is black star only. So you will see in Kiali here that all traffics in green is basically going through version 2 of my microservice application. Now, one of the functionality that you can use is actually fault injection or chaos monkey. So I just applied a traffic control in my application. As you can see, there are now errors on the front end of my application. And it will also show in my Kiali UI, because this is showing almost real time. As you can see, there are orange and red application there. And if I go to Jaeger, I can see that there are error. And if I want to dig deeper what this error is about, I can also do that in Jaeger. And this is actually useful for troubleshooting purposes. And that's basically the end of my demo for Service Mesh. Now, next slide, please. So next I'm going to talk about is serverless. In Arrow 4.3, this features is actually tech preview, but the current release of OpenShift, which is 4.4, this is already GA. So what is OpenShift serverless? OpenShift serverless is based on an open source project called Knative, one of the fastest growing serverless projects in the market, I can tell you. This ensures that you don't also suffer the lock-in concerns that and can still get the innovation from the growing open source community. Next slide, please. So when I talk about serverless to different people that I met, many of them, well, think of serverless about AWS Lambda or function as a service. But in reality, or at least in Red Hat's perspective, as well as CNCF, serverless concept is actually broader than function as a service. If you compare serverless to function as a service, it's like saying function as a service is serverless the same way that you say square as rectangle. Next slide, please. So OpenShift serverless is basically based on three Knative features, which is building. In OpenShift 4.3, we use Tekton. Eventing, basically, is you can use sources such as Kafka message, file upload to storage, timers for recording jobs, and sources like Salesforce or ServiceNow, and even email. And this is powered by Camel K AMQ. And the third features is serving. Now, in OpenShift 4.3, the features that you can use for now is only serving. And that's what I'm going to show and talk to you about. Serving is a module that receives the output of build and responsible for running the container in the event-driven world. This allows for auto scale on demand, but also scale to zero, which is how you want the concept of serverless, which is critical for serverless workload and can expand the density of worker nodes and cluster tremendously. So next slide, please. What I'm going to do now is I'm going to do a demo of serverless. Can you play the video? Right. So here I created already a namespace code or project called Knative Serving. That's where I'm going to deploy the serverless operator. So going back to Operator Hub again, I'm going to choose or look for serverless operator. And then subscribe to that. I choose the version 4.3 for this specific deployment. Now that I have the OpenShift serverless operator deployed, what I need to do is I'm going to create a Knative serving instance. Knative serving instance is what we are going to use for the demo to show the functionality of serverless in OpenShift. Now that I click the creation, it will actually show you pods or containers that is needed for me to use Knative. So it's currently being created. So here I'm just showing you guys the resources that is being created as part of this deployment. So these are the pods that is needed for me to use the features of serverless. Now what I'm going to do is I'm going to create a serverless demo project where I am going to create an application. So in my GitHub, which I'm going to show, I have a small Golang application. And this application will create a hello world service. So when I did this recording, I need to update some of the serverless, the YAML file. And after that, I created successfully an application. So here, I'm actually trying to show the serverless tab that is created additional to the normal tab in OpenShift admin cluster UI. I go to my developer UI. This is now the application that I just deployed in a command line. This is the Golang application. So now I trigger an access that triggers the creation of the container. So it shows me that I have the hello world working and the application actually scale up from 0 to 1. Now what I want to do is to show you other functionality of serverless, which I can control traffic, of course, using UI or using command line on the application or service that is running. What I'm doing here is update the deployment config. Now that you see, there are 2 revisions now. So, with 2 revisions available, I can now set a traffic. Say, for example, a 50-50 or a 50-50 split of traffic going to an application. So let's call it split 1 and split 2. I'll just choose the right container which is available for me, and using the command line, I can show or that there will be 2 endpoints in the same URL. Now that it's split in 50-50, I need to click one more times, and it actually creates the second container or spin up the second container. And in a while after that, it will spin up to 0 as well. So here, what I'm trying to show here is I will be showing how you can access serverless using the UI. So I used my Spring Boot GitHub. I can see that there is actually a Knative functionality right away on the build config, and I can update the the scaling, and I can even use the labels. And of course, labels are important if you are using service mesh functionality, so that you can you are aware of the application utilization within that specific project. So this is just me showing that it's possible for you to do that as well. So in that other application shows that it's scaled down to 0 as well. And here I'm just showing what capability or what features you can get as well, and you can access from from developers UI. Here I am actually showing the populated serverless features already here that shows the available routes and shows the revisions as well as the service. And that concludes my demo. And I'll give back to Clarence for the next topic.
Thanks, Mike. Oh, great demos. So, so now we understand that Arrow at its core is OpenShift container platform, but it's a managed service and has the familiar Azure tooling to create, monitor, and scale the cluster sort of surrounding that. So let's look at some of the other native integrations for Arrow from Azure. So next slide. So we've talked already about single sign-on. So one of the first things you'd normally do is set up the identity provider. So on Azure, that's going to be usually Azure Active Directory. Now you can set up multiple providers. So for example, maybe for internal users, they use Azure Active Directory. And if you've got maybe some contractors or external users you want to manage in a different identity provider, you can have more than one set up. Next slide, please. So another interesting one is the Azure Monitor integration. So by default, you'll get Prometheus and Grafana set up in your Arrow cluster for getting observability into the performance and metrics and logs of your applications and cluster. You can also use Azure Monitor to externally monitor the cluster. And this is useful if you're already managing other resources on Azure in your subscription. For example, like maybe you've got multiple clusters, you've got on-premise clusters, maybe you've got other types of clusters like AKS or something. You want to have a unified single pane of glass to sort of get an overall health view. You can use this integration. It's currently in preview, and you install it from the command line. In future release, we'll have this more integrated, where essentially like a checkbox in the portal or a command line argument when you create your cluster to activate that integration. So you can see there a screenshot of what you kind of get in terms of cluster and node utilization, and you can drill down to individual containers to see their logs as well. Next slide, please. So the other aspect is scaling your node. So we saw how you could scale pods, you can scale using the Knative serving, for example. But there's times when you need to scale the underlying infrastructure, so the underlying VMs or nodes. Now, OpenShift supports auto scaling through what's called the cluster auto scaler. So this is essentially based on the upstream Kubernetes auto scaler component. And another concept that OpenShift has is machine sets. So you define a machine set for each type of node, and you can set up a machine scale set to set up lower and upper bounds. So for example, in this slide, you can see we've set min workers to 1 and max to 2. Now we can actually then have the cluster autoscaler drive the scaling of those scale sets automatically. So if we start launching a lot of pods, for example, in our cluster, they'll hit a pending state if there's no more capacity. And that's an indicator to the cluster autoscaler to start creating more nodes or more instances. So then we'll start getting VMs created on Azure through our cloud controller that's integrated with the Azure platform. Next slide, please. There are quite a few other integrations. Just highlight a couple here. So for managing secrets, so at rest, the secrets are already encrypted in Arrow or in OpenShift. If you want to store your secrets externally, you can use Azure Key Vault, which is Azure's secret store. And we have a driver that you can, so currently this is a component you install yourself just through like a Helm chart. It will then allow transparent access to those secrets. So that means you don't need to change your apps to know how to talk to Key Vault. They just receive their secrets through a mounted file, for example, or environment variables, and this driver will then retrieve those secrets from Key Vault and make them available to your pods or workloads. And lastly, there's the Azure Container Registry. So in Arrow, you have the OpenShift Container Registry, which is built into the cluster. Red Hat also have Quay, another enterprise-ready container registry that you can either self-host or use a SaaS offering. And if you're already using Azure and using containers elsewhere in Azure, you can use the Azure Container Registry for OpenShift as well. So to make use of this, you just need to update what's called the service principal, which is like a service account, if you like, that is used when you create the cluster. You just need to assign a role called ACR pool to authorize the cluster to be able to talk to the Azure Container Registry. Now, before we move into the closing, I want to just show you a couple of things very quickly. Right, so you should be able to see my screen now. Can I just get confirmation of that from one of the speakers?
It's buffering.
Showing up. Yeah.
Got it? Yep. Yeah, so just quickly, before we go into the closing, just want to show a couple of things. So we have documentation on setting the Azure AD integration that I was talking about. So for example, here, we can see on my cluster, I've actually got an additional identity provider here, which is Azure AD, and you can have multiple identity providers. So because I'm already signed in previously to the Azure portal, you'll notice that when I click on that link, I'm seamlessly signed in using my Active Directory, Azure Active Directory identity. Now, the last thing I wanted to show you is Arrow will have the built-in Prometheus and Grafana for components for monitoring, which is great. This was the Azure Monitor extension that I was talking about. So if you're already managing other clusters, for example, here I've got some AKS clusters, and then I've got my Arrow cluster showing up here. I can see it at a glance what's going on, and you can drill down into that cluster to see overall health. So here's my cluster, the utilization. I can go down into the specific health to see the components that are running in there and the nodes. And you can drill down further into the individual nodes, the pods that are running on each node. And eventually you can get down to the containers and you can see their logs. Okay, so next slide, please. So we hope you've enjoyed this webinar and gained a good understanding of Arrow 4 and are keen to try it out. This is, as I said, it's a jointly managed offering by Microsoft and Red Hat. And if you haven't answered your questions, or if you've got questions that you want to ask, you can feel free to type those into the Q&A box now. Now, we value feedback from all the attendees today. So there will be a feedback form link that will be posted in the Q&A box. So just have a look for that now. And there's an optional opt-in if you want any follow-up engagement from either Microsoft or Red Hat. So you can opt into that if you're interested. Next slide. One more slide. So there's a few resources just pointing out here. If you want to learn more about Azure Red Hat OpenShift, you can see that link at the top left. The top right link shows you how to get started creating a cluster like we went through earlier. There's also an FAQ if you understand some of the limitations, roadmap, etc. Frequently asked questions, have a look at that link. And lastly, if you've got feedback for the product team, so rather than us, but like if you want to provide feedback to improve the product or potentially influence the roadmap, then you can submit feedback via that link in the bottom right. So once again, thanks for watching. We hope to see you in future webinars. We'll stick around to answer any questions that you have, and please submit any feedback you've got via the link in the Q&A box. Thank you.
So we're around for 5 minutes or so, yeah?
Yeah, we'll stick around for a few minutes.
Great. Should we read out some of these questions? I think that could be a useful kind of way to spend these 5 minutes. There's been some good questions coming through, which I've answered some, Mike's answered some, and Clarence has answered some. So yes, there's one here at the moment we haven't answered. On a high level, what are the typical tasks of operators, admins versus tasks of devs? I guess at a high level, an operator is really something that you would do as an administrator. Devs don't necessarily need to either see or deal with the operators, but you can set up, say, an unprivileged level of access for developers to a subset of an operator, which they might find use something like I need to deploy a cluster of a new Grafana cluster for my project. You might make that available as an operator. And so it's more of a consumption versus administration options there, depending on what your role is.
Yeah, in my experience, based on my engagement with our customers, developers usually creates the operators and give it to the day 2, day 3 type of people, because they want to make sure that all their deployments are based on their standards. So as what Joel explained, operators handles administration tasks, but really if you want to use, there are different kinds of language that you can use in creating operators. Go is of course there. You can use Ansible and you can use Helm. Other customers of ours use Java to create an operator. So yeah, there is also an operator SDK that you can use, which provide frameworks on how you are supposed to create operators for OpenShift. And
I think I mentioned previously as an answer in there is that operators are not a Red Hat specific or OpenShift specific thing. They're a Kubernetes upstream project. What we're doing is we're working with various vendors, and they can be a security appliance vendor, they could be a middleware vendor, to make sure that if they're delivering a container-ready application stack, they do it via an operator. So effectively, at its most basic, if it's just a deployment method like a MSI installer on Windows or an RPM in Linux, that's what an operator can be. But at its most complex, some of the operators include things like machine learning pipelines to auto-tune themselves. So they might do a scaling of a database platform that's deployed as an operator and automatically scale up the number of worker nodes for that database platform, do all the replication required, all the cores, all the syncing operations to make that completely seamless to the end user. Operator is a person, right? Yes. You wouldn't expect an operator versus a dev to have to actually be installing or using OpenShift from scratch. I mean, that's a dev would just go on to get the namespace and start using it, right? So.
Yeah, I think OpenShift in my perspective enables DevOps so that devs and ops can work cohesively, and this is a perfect platform to do that, because it enables developer to deploy or develop application on a stable environment where operators manage the type of infrastructure tasks to make to water and feed and provide that platform for developer to continue working on their development, really.
Yeah, and I mean that's something I talked to right at the start, right? One of the big things between Red Hat versus the community is that the community have goals and aspirations that enterprise customers may not necessarily have or be aligned to. And even where you go to an upstream first approach, there's always going to be this disconnect between what you need to deliver to actually drive value for your business and what you actually have to deal with in terms of the project. And so the point of OpenShift is to make Kubernetes into something that's able to deliver your business value, and which in digital transformation terms effectively is your applications. So it is very developer application centric because that's effectively what businesses do to digitally transform.
All right. Looks like we've answered all the questions. Thanks again, everyone, for attending. We hope that you enjoyed this webinar. We certainly did. And we hope to see you again soon. And please get that feedback in. And go ahead and try out Azure Red Hat OpenShift.
Thanks, guys.
Yep. Ngā mihi nui. Tēnā koutou.
Thank you.